Hello, everyone. Can you
Hello.
get yours okay?
I think we assume we're good, Ricardo.
Perfect, perfect. Thank you so much for joining us. Um, this is the micro fulfillment simulation labor modeling presentation. Um, Presenting today is myself, Ricardo Yugas. During the work of this case, I was working as a consultant in the micro fulfillment group within Dematic. I'm still within Dematic, just a different group at the moment. Just a little bit of background. I studied engineering during my undergrad at Miami University. Then I studied business analytics at Harvard. I'm currently in the UK pursuing my master's in international business. Hoffman, why don't you introduce yourself for a bit?
So I'm Stephen Hoffman. I'm coming to you from Grand Rapids, Michigan. Ricardo's in Cambridge, England right now. My background is with automation and dovetailing software management systems with automation to serve a specific function. So without stealing the thunder, we've explored AnyLogic to kind of help us do labor modeling when we have to combine automation with manual aspects of an operation. So Ricardo, take it away.
Yeah. So, for the agenda for today, we're going to give a quick intro into what the Matic does, give an executive summary to the case of AnyLogic, some of the business challenges that we try to address with the simulation, go over the simulation itself, some of the data results, an overview, do a quick summary and conclusion, and then we'll end up with some time for Q&A. Um, cool. So to start off, Dematic is a trusted partner in the warehouse automation industry. It designs, builds, and supports intelligent automated solutions. We help customers power the future of e-commerce through manufacturing, warehouse, and distribution through material handling equipment. So sorters, conveyors, palletizers, storage and retrieval systems, um, AGVs, robotic picking, and so on.
So
Um,
we're both a manufacturer and a project company. So we design and build these systems, and we integrate with equipment that we don't make. But our main focus is 80% distribution, 20% manufacturing, and we're a global entity.
Yes, Dematic is also owned by Kion Group, who's the parent company based in Germany. Um, so starting off, the case in which we begin to use any logic, or the, I guess, the focus of it was in micro fulfillment. And micro fulfillment is essentially you used to fulfill online orders from an existing retail store, generally located in an urban region, to leverage its close proximity to customers to meet ever increasing demand. A defining feature of micro fulfillment is the goods to person automated picking technology, used to expedite picking process, reduce labor cost, ensure that orders meet high quality standards, and reduce friction of shopping with in-store customers. Orders can be fulfilled by picking from an automated storage and retrieval system or a mixture of both manual and automated picking. The diagram below is created to provide a general overview of where micro fulfillment fits in relation to other types of order fulfillment facilities. And the values provided in the diagram serve as just general guidance. They don't necessarily disqualify retailers from what could be a micro fulfillment. But we have anything as something as small as like a bodega style and nano fulfillment, all the way to a large distribution center used by some of the biggest online retailers. And we're kind of on the smaller end of it, where generally the space for a micro fulfillment is about 20, 30,000 square feet. Anything you would like to add, Hoffman?
It's just, again, I'll reiterate that our challenge is the labor required to run a system that includes both automation and manual aspects. So when we're executing work, We have certain parts of the work that are fulfilled by operators working with the automation. We have food that we have to pick that's stored in multiple temperature zones, chill, ambient, and frozen. We pick fresh produce, which requires different um, activities to scan and weigh. Sometimes to that affects your labor standard for how fast you can pick something. But again, the challenge is the machine can do a rate, the customer needs throughput. So AnyLogic can help us in both of those. It's not perfect, but it can get us there. We can cover a lot of ground. The first 80% goes really fast. The last 20% could take months. So anyone who's done a model can attest to that, that you can fine tune it forever, but you can tell a really good digital story with out of the gate fast, and then refine as necessary.
Absolutely. So continuing on in the executive summary, so a critical factor identified for retailers preparing to go live, and in this scenario, we're talking about grocery retailers with a micro fulfillment center in the back of the grocery stores, is to set up their operational readiness framework, which is staffing is an essential element in this framework, since the incorrect number of people, working hours, and shifts can negatively impact the retailer's ability to meet its customer promise. We work very closely with different a number of grocery retailers to help them better understand the labor model for them. Um, and a lot of them, the retailers not only value getting a robust understanding of the staffing required to operate its micro fulfillment, but also um, we're interested in learning how different scenarios will impact its ability to fulfill orders. For instance, it was critical for them. It's critical for them to understand how labor could be impacted if a picking station goes down or a decanting station goes down, or if there's a bottleneck in any step in the process of fulfilling an online order.
Key to the or what's interesting about a day in the life of the system is the orders that we're picking again are some are for click and collect, i.e., the customer will order and pick it up at the micro fulfillment center, and then that's probably 30%. The other 70% of the orders are probably picked and loaded into delivery vehicles for home delivery. And you have different high concentration periods during the day. You may have a morning, mid-afternoon, and evening delivery times that are highly concentrated, and then pickup times dispersed evenly kind of throughout the day. So if someone shows up for an order, it's going to be picked before they get there, but once they're there, they want it in their hands within 5 minutes. So you have to dovetail and balance that labor with the home delivery orders that you're pulling out and staging and loading. So it's a balancing act. The machine can go super fast, but it can actually out overflow your space. You don't have endless space to store orders once they're picked. So again, dovetailing these operations and not overstaffing nor understaffing is key, and shifting the staff when needed from picking to delivering out to someone's vehicle, to picking in the store itself, to picking water and dog food off the floor in the back of the store. It all has to come together to make a return on investment on the equipment and the model for direct-to-consumer grocery.
And just kind of for reference, on the bottom right, that image shows an example of a micro fulfillment. So that will be essentially the type of automation that could fit in the back of a store. So it's about a 3 aisle system with three goods to person picking station, in the decanting in the back, and we'll go over a little bit what that looks like in the simulation as well.
It's about a 15,000 square foot footprint in a 100,000 square foot retail store.
Yeah. And I apologize, coming out of a cold, so my voice can be a little bit raspy. But in terms of how we chose AnyLogic, the way that we started by understanding what kind of simulation tool to use was, um, we knew that this common knowledge gap among grocery retailers of the labor, along with our continued development, kind of inspired the development of a simulation tool. But we began the research by reaching out within the company, understanding what was currently being used, what tools were within our reach internally. A lot of them were things like Automod, traditional coding tools with Python, and one of them was actually AnyLogic. We chose AnyLogic for simulation modeling because of its low coding, its material handling library, and its tutorials, um, literature, as well as online support community. We were drawn to the ability to create visually appealing simulations that we could show our customers and back up the visual elements with real data that we could export for additional analysis or validation. In addition to the ability to upload the model in the cloud and allow us to reach other teams within the company and allow them to experiment with a model that they would otherwise not been able to use.
Okay, so we're about 10 minutes in. So I think the next slide is what's interesting, Ricardo. So it actually gets into the model. And again, it is a work in progress. I mean, I guess we're not quite there, but let's get to that model as we're 10 minutes in.
Gotcha, gotcha. I think we have one before it, and then we'll get to it. But essentially, this kind of shows the complexity of what we had to simulate. There's a lot of processes within inventory management, picking, order marshaling, and delivery. Um, a lot of things to be considered within the model. Um, and some of the key features of it that we were really interested in having was the ability to upload the customer order data, staffing schedule, the ability to adjust rates, prioritize task zones, and capacity constraints. So we'll go ahead and jump into the model and show what that looks like. Um,
And it's interesting when we're building the model, there's libraries to choose from. So when you combine the material handling library with maybe the pedestrian library, which is kind of what we're doing to figure out what can tell the story the best. Um, Again, the first 80% goes really quick, and the results you get from seeing the labor move in action is very compelling. And we were able to get there without writing a lot of custom code. And then we started incorporating tables to do custom load times, demand increase in the demand or decrease in the demand by hour. So I'll let Ricardo describe the model and some of the inputs.
yes, so while it's kind of loading, I had preloaded it, but it's giving us a little bit of technical issues as computers do sometimes. Um, so some of the key features of it is that this is the home page. Just went away. Lovely. Let's see. Okay, cool. It seems like it's coming in and out. Okay, cool. So let me just start it from the beginning. So this is the home page. Um, is the team able to show it on their end? Sweet. So this is what the homepage looks like. My apologies. So we have a series of parameters that we can play with. One of the things I mentioned was the ability to upload customer data. So in this scenario, we are uploading order data, uh, real time, hour by hour, as well as uploading staff schedule. And some of the other things that we can adjust are critical parameters, such as the distribution of the orders that are going to be picked by automation as opposed to manual, or other areas. We can adjust the number of people that will be working, the number of picking stations, decanting stations, um, rates, and we're using distribution when it comes to those rates. So the simulation doesn't just use the fixed number that we put in. We can also adjust how long we want the simulation to run, which in this case we chose 24 hours. Um, Other additional, more advanced things include capacity constraints. So, for instance, if we only want two people to do truck unloading, we can specify that so that the simulation doesn't just allocate everyone or as many people that don't realistically fit within the space. And then the last thing is the ability to adjust the priority levels. So we can identify some of the most important tasks and make sure that those are prioritized so that they don't become a bottleneck. The example that Stephen gave was click and collect. Was as soon as the customers are there, they want their order within 5 minutes or so, and that's something that we can prioritize. And after that, we hit start. The model essentially reads the data and begins to simulate for us. So we have on the top four tabs: statistics, 2D view, 3D view, and results. And we can go through all of those to see different um, types of information. So if we wanted to show the customers this is the visually appealing part, different sections of their facility, how they operate. The results part essentially gives us an hour by hour um, a breakdown of how many people are working, where they're working, um, the total number required, the staff utilization, how many orders are we able to fulfill with the number of people that we've simulated, and a lot of details like that. Next, going back to the statistics page, we have a process flowchart over in the left, which is the idea is that it simulates the real simulation um, or the real processes within micro fulfillment. Then we have a summary overview that allows us to see how many orders have been dropped, how many orders have been picked, what's left to be completed, um, and things like that. Um, in addition, kind of going down in the order fulfillment section, we have a little bit of an application of queuing theory, where as the orders are being dropped every single hour, even though that's not how our software works, our software essentially drops the orders real time. It allows us to understand whether people are being able to catch up with the orders, catch up with the work, see if we have a, a good number of people within the different areas and things like that. And then on the bottom right, those sort of charts allows us to see the distribution that the simulation is using for the rates at which people are working in the different areas, as well as the automation. Um, Huffman, do you have anything that you like to add on this as well?
Yes, there's a couple of questions I'm trying to field online while you're speaking, but limitations of the model. At this point, the model we just had to kind of give a rate for the automation. So the automation it looks like the blue ice cubes, which is an automated storage and mechanism or storage and retrieval mechanism. So that will have all different types of groceries in it. So we can't exactly simulate when I've got a bunch of orders that all want the same salad dressing at the same time. So at this point, we're giving rates and giving an estimation so we can accurately, as best as possible, as reasonable as possible, predict the labor that's going to be required for a day in the life of the system. If we actually took real data, we would see some days that are, that are going to be peak, or some hours that are going to be peak higher than this, some time slots that are going to vary. So if you, the ability is in there in the tool, but it's just going to require a next level of coding that you have to decide whether going to that next level, and simulating where all the inventory is, the stock levels of every 10,000 items in the system. That ability is there. You just have to decide how far to go with your with your AnyLogic simulation. If you're just trying to get buy-in that this machine with this labor component makes sense, um, if you got the buy-in, you maybe don't have to go to that next level. If someone says, I'm not buying it, my inventory fluctuates, my demands change at Thanksgiving and Christmas, I got to see what that looks like. That's always a deeper dive. So that's, you have to make a decision from a consultative perspective. How much time is that going to take? And if I'm charging for my time, what's the added result for spending another 2 months on the model versus where you are now? So the strengths of the model, again, from my point of view, is it gets you a visual digital story uh, that people can resonate with and help you get buy-in through all levels of an organization. And you have that added capability if you need to take it to real specific fluctuations in the day in the life of the system. You can, but you always have to make that decision of how much is enough. And if I've got a guy and I want to dedicate him for another 3 months to get 2% better, is that worth it? But we, in a short amount of time from being AnyLogic novices, um, just by experimenting around, again, like in the first 2 days, we were able to get some pretty powerful visual results that were compelling. And then we probably spent another, 4 to 6 weeks refining the model and inputting the data from the tables. Um, and we could spend another year to really dial it in and still not hit production exactly how it's going to happen. But those, again, if we wanted to, I think we could. If we wanted to take actual order data from the day in the life of a system, and get into some of the delivery schedules and talk about what happens when a delivery vehicle blows a tire. How does that make the model back up? Endless things you can dive into, but again, pretty powerful stuff in a short amount of time.
Yeah. Um, I agree. I don't know how much time we have left, but just to kind of go over real quick one of the final slides. Um, this is sort of the data output that we can then present to and we present to customers, where we can demonstrate the total number of people required each hour, where they were working, some of the limitations as Hoffman was talking about are maybe some of the assumptions of the model. um, it is assuming that things are working more or less at a steady state, that there aren't any disruptions to the system. So if we did want to simulate any type of disruptions, we will have to run another simulation, and then we can um, have hundreds and hundreds of simulations as we have more and more questions, because each process can have its own a disruptive step that can cause a bottleneck. But
We
in
we
essence,
and yeah,
go.
we are asked, what will you trade off if you want to reduce the model complexity? The if the ultimate trade-off is the system requires more labor when it's in production. So the trade-off would be you maybe estimated labor. If you estimated labor 10% less than it was required based on some unknowns, that might be acceptable. If you estimated labor 40% than what's required, then you're going to have a problem with the return on investment of the model. So as you're talking to the recipients of the model, that's what you have to say. You just have to be honest with some of the complexity that's not part of the model, and make an estimate as to how that would affect labor one way or another in this instance that we're going for. And if we wanted to take it to a level of what happens if someone who's manning an automation station takes ill and needs to leave their post, um, the work would start to back up, and how does that affect deliveries and if I have to drive the work all to one station now. I don't know if that's a perfect answer to your question, but it's always you give up a little accuracy when you reduce complexity.
Exactly. And as Huffman mentioned, I think he said it very well that this model essentially can get us 80% there, and that remaining 20% will require some additional analysis that can take a pretty long time. But um, at least within the company at this time, this is one of the most advanced ways that we can um, present with confidence the level of the best labor model for them.
Yeah, just as a automation provider, the automation provider generally talks about rate, how fast a machine can work. A customer generally, there's a purpose for that machine, and they have processes, so they're more interested in what they would call throughput. So if your machine is capable of 600 movements in an hour, and the customer needs to translate those 600 movements into orders out the door, that's a throughput conversation that you have to dovetail the capacity of a machine to the operation, day-to-day operations of what you're trying to solve with that machine, which is always a challenge for any automation provider. In manufacturing, it's pretty straightforward. If I'm filling the same bottle of aspirin over and over again, you can get 98, 99% efficiency in a process like that. When you're doing mixed case fulfillment, where you're dealing with ice cream and fresh produce and soft drinks, macaroni and cheese, tuna fish, all different sizes and weights, and different demands. Usually there's an 80-20 demand Pareto curve of 80% of the volume comes from 20% of the SKUs. So again, getting all that balance and doing a reasonable estimation without taking things too far and spending too much time again.
We have another question. I believe it's from Mike Rogalski, which is the model used by clients on a more or less ongoing basis or mainly upfront when planning a facility? So currently, it's upfront at the process execution phase, um, and in the bid proposal phase, and there are further discussions about finding ways to do further consulting um, um, to help ongoing or existing customers.
Okay, I don't know where we are on time, but happy to field any last minute questions if there are. Hopefully, this was not a waste of time and was interesting. I know we recorded the model just so we wouldn't have any hiccups in regard to the recording. So that's it from us here at Dematic. We hope it was informative.